All right, so let's look at number one. What's the symbol for the correlation coefficient? The population correlation coefficient is rho, which looks like a P. So I'll select that. If you need to pause the video, you can. What's the symbol used for the slope for the population of the least squares regression line? That's beta. So that's beta. 3. Let X be a random variable that represents the percentage of successful free throws a professional basketball player makes in a season. Let Y be a random variable that represents the percentage of successful field goals a professional basketball player makes in a season. A random sample of 6 professional players give the following information. And so we're going to use a 5% level of significance to test that claim that rho is greater than 0. So my null hypothesis is I'm going to assume that rho is equal to 0. How do I enter this in here? I'll delete this and show you. So I'm going to go to Greek, select this P, which is rho, equal to 0. And what I'm assuming is rho is greater than 0. I'm trying to prove that they have a positive correlation. So I can delete this. I'll go to Greek, select rho greater than 0. Oops, sorry about that. Now, how do I calculate a test statistic for this? Well, what I could do it by hand, but I'm going to cheat on this. I'm going to go to stat enter. In L1, I'm going to put all my X's. In L2, I'm going to put all my Y's. Okay. All right. So now I'm going to go to stat. I'm going to go over to test. I'm going to go down to the very bottom, which is linreg t-test. Linreg t-test. Okay. And this test will give me a test statistic and a p-value. Now this test works for beta and for rho, and so we're going to use you'll use the same test for the bottom part of this as well. So L1, L2 are my list, greater than 0 because of this, and then I'll press calculate. And so my test statistic is 2.94. I believe they want 2 decimal places there. My p-value is 0.0211. So 0.02, that would be this one. Now, let's go evaluate my p-value compared to my level of significance, 0.05. So how does 0.02 compare to 0.05? It's less than. When p is low, we reject the hoe. So we reject the hoe, and so when you reject the hoe, that's like guilty. So we have sufficient evidence to say that the population correlation coefficient is greater than 0. All right. B, find the predicted percentage of Y hat for successful field goals for a player with an X equals 77% successful. I did not mean to click that. Sorry about that. So what I'm going to do here is I'm going to go make my equation out of this information. I can make an equation out of this where my A is my Y-intercept. So Y hat equals 13.706 plus B is my slope. I'm just plugging into that formula. B is 0.446x. And what I'm going to do is I'm going to plug in 77 into this equation here. 77. Okay. So 13.706 plus 0.446 times 77. You get 48.048. So we want 2 decimal places. So it'd be 48. I got 48.0 or now 48.05. Okay. Find a 90% confidence interval for this one. Okay, so I did not cover this in the notes, and so this is something I'll have to show you here. Now, the confidence interval, we first want to find the margin of error. So the margin of error is going to be the critical value of t times the standard of error times the square root. And by the way, they give you most of this up there. Times the square root of 1 plus 1 divided by n plus n times x minus x bar squared divided by n times sigma of x squared. So the sum of the x squared minus x squared. Okay, so this is a lot of work here. Now, TC is the critical value, so I'm looking at a 95% So 95% here, or 90% confidence interval. I'm sorry, 90%. So I need to have the 90%. So I'm going to go to find that critical value. So for 90% confidence interval, I go to, second bars, inverse T. Now, here's the key, though. If I have a 90% confidence interval, I want the T at the high end. So my area is actually going to be, let me write this. It's actually going to be 0.95 because I have it 90% plus this 5%. So inverse T at 0.95. And then the degrees of freedom here is n minus 2. So n minus 2. And so my degrees of freedom here, how many do I have in my sample? Let me go check. I have 6 in my sample. So it'd be 6 minus 2, which is 4. So that gives me my critical value, 2.132. Now my other values I can get from up here. So S of E, you see it's right here, 2.5039, okay, times the square root of 1 plus 1 divided by n. N is my sample size, which is 6 because I have 6 data points, plus now n is 6 times each x times my x minus my x bars. Okay, let me move this. So x is the value that I'm plugging in, so it'll be 77, okay? Minus x bar, which is the mean of the x's. So the mean of the x's. So what I got to do is, I've got to go to stats, calc, 1 bar stats, and I got to find the mean of my x's. So it'd be 73.167. Okay. Squared divided by 6 times e of x squared, which is 32,393, minus the sum of the x's, which is 439 squared. Okay. It's a lot of work here. And that's just going to give me the margin of error. So I will do, let's do the square root. So let's 2.132 times 2.5039 times the square root of 1 plus 1/6 plus, and then I'm going to put this on top, open parenthesis, 6 times parentheses 77 minus 73.167 close parentheses squared, close parentheses to close the top, divided by open parentheses 6 times 32,393 minus 439 squared. 5.897. That is my margin of error. And so what I'm going to do is I'm going to add and subtract that to the predicted value. So I'm going to do the predicted value plus or minus that margin of error. So 48.048. I'm not sure how many decimal places they want. I should have looked at that. 1 decimal place. Okay. So 1 decimal place. Minus 5.897. Okay. And then this plus. So this would be 42.151 and 53.945. And so actually we got to go 42.15. Let me erase this because they want 2 decimal places. So 42.15 to, and this is 95, to 53.95. Now we're going to do the 5% level significance to test the claim that beta is greater than 0. So we're going to assume that beta is equal to 0, and we're trying to prove that it is greater than 0. So I'm going to go to beta greater than 0. Now the nice thing about this is the sampling distribution value of the test statistic, it will have the same value. So I go to stats, test, linear regression t-test, because it runs the same statistic. It'll run the same test, different parameter, but it's going to run the same test. So calculate 2.94, and then my p-value is between 0.01 and 0.05, and so that's less than the 0.05. So we're going to reject Ho. We have sufficient evidence it's greater than 0. Find a 90% confidence interval for beta. We could use our calculator for this. We can go to stats, test, linear regression t-interval, option G, L1, L2, 90%, 0.9. And we could do that right there. So I get 0.123. They want me to go 3 spots this time. 0.123 to 0.769. Interpret the meaning. All right, so we're going to say, we can say with 90% confidence that for every percentage increase in successful free throws, or percentage of successful field goals changes by the amount that falls within the confidence interval. Okay, so for the percentage of every increase in successful free throws, that the percentage of successful field goals changes by the amount that falls inside the confidence interval within. Okay. Make sure that worked out. Oh, there's a problem here. I think this was 0.04. I apologize. I think they didn't like the rounding or something here. May have rounded in the wrong direction, which that's the thing on this. I used more decimal places than they did. I should have just used 2 throughout, and so it cost it to go that way. So that was the problem there. All right, let's go to number 4. Let X be a random variable that represents the batting average of a professional baseball player. Let Y be a random variable that represents the percentage of strikeouts. And so we've got a 5% level of confidence to claim that the population correlation coefficient is not equal to 0. So my Ho here is going to be Greek rho equals 0. I'm trying to prove that rho is not equal to 0. So I'm going to do the exclamation point equal sign. Now, test statistic, what I'm going to do is I'm going to enter these values into my calculator. So stat enter. Okay, let me move this over. 0.328, 0.290, 0.340, 0.248, 0.367, 0.269, and then my Y's are 3.3, 7.7, 3.9, 8.5, 3, and 11. So how do I do this? I can go to stat, test, and I can go down to linear regression t-test, L1, L2. Now this time it's not equal to 0. Calculate, and so I get my test statistic, which is negative 4.02. My p-value is 0.015, so that would be in between 0.01 and 0.05. Now, what was my level significance? It was 5%, so is that less than 5%? Yes, so I will reject Ho and say there is sufficient evidence that differs from 0. Okay. Now, find the predicted average for strikeouts for a player that the batting average is 0.340. So I'm going to use this. Now, I got to be careful. Last time they didn't like it because I think I'm going to write this out here. Y hat equals 26.19. I'm going to go 2 spots in all this, okay? Because last time I went 3 spots and they didn't like my answer. So, and then the B is the slope, minus 65.00 times x, and my x is going to be 0.340. So 5 times 0.310. Okay, or 340. Sorry, 0.340. So 26.19 minus 65 times 0.340 gives me 4.09. Okay, so that gives me the right answer this time. So I tried to be an overachiever last time. It didn't work. Find an 8% confidence interval. This is what I did not go over in the notes, but I could show you how to do it. The critical value, let's find that first. T of C, it's 90% or 80%. It's the middle 80%. So I need to know there's 10% there, 10% there. So I need to know the T at the high end. So that'd be 0.9, be my area. So inverse T. Inverse T, 0.9. And my degrees of freedom, I have, I believe, 6 data points this time. 6 would be n minus 2, which would be 4. So inverse T, 0.9 and 4. 1.533. I'm going to go 3 spots here because the other ones were 3 spots in the other statistics. So T of C, so the error equals T of C, which is 1.533 times S of E, which go back up here and find that. 1.6, actually they went 4 spots, so we'll see how this goes. Times the square root of 1 plus 1 divided by n, 1/6, plus n, which is 6. Now my x, what am I plugging in? 0.340 minus my mean of the x's. I don't think I have that on here, so I'm going to have to go find that. So stat, 1 bar stats, so I need to find the mean, 0.307. That's squared divided by 6 times the sum of the x's squared, 0.5758 minus the sum of the x's squared, so 1.842 squared. Okay, so I'm going to enter this into my calculator. This will give me my margin of error, 333 times 1.6435 times the square root of 1 plus 1/6 plus 6 times 0.347 minus 0.307 squared divided by, parentheses, 6 times 0.5758 minus 1.842 squared. Okay. 2.897. So I'm going to take my predicted value, which I did not write down here. Let me go back here. My predicted value was 4.09. So I'm going to do my predicted value plus or minus my margin of error. So 4.09 minus this, 4.09 plus this. And so we get 1 point, and this is a little off from this one. Looks like I'm a little off here. 1.193 to 6.987. Make sure I entered that in there right. 307 squared, 0.340. Oh, I didn't enter this in here right. I'm sorry. So my margin of error was wrong. So this is 2.842. I didn't enter this in my calculator right. So let's try this again. 4.09 minus, apologize for that. So I got 1.24, 8, so 1.25. So 1.25 to 6.93. So 1.25 to 6.93. Now for beta, we're assuming that the slope is equal to 0. So beta let's go to beta. Where's beta? Beta equals 0. Sorry, that didn't go through there. Equals 0. I'm trying to prove it's not equal to 0. So beta not equal to 0. The sampling distribution. So this is going to be the same t statistic as above. I can go run the test real quick. Linear regression t-test. Okay, not equal to. It's going to be negative 4.02. Same p-value and same decision because it's less than 0.05. So we're going to reject Ho, and we're going to have sufficient evidence that it differs. Okay. A 90% confidence interval for the slope. So what I do is I go to stat, test, linear regression t interval, L1, L2, 0.9, or 0.8, I apologize, 0.8, or 90%, never mind, 0.9. Okay, 90% confidence interval, negative 99.45 to negative 30.55. And then we can say 90% confidence interval that for every unit increasing batting average, the amount falls within the interval. Okay, we can say with 90% confidence for every unit increase in batting average, it falls within the interval. Okay. All right, let's try the last one here. So we're going to do on this one, use a 1% level of significance to do the claim that rho is less than 0. So we're going to assume that rho is equal to 0, and you're trying to prove that rho is less than 0. So what I'm going to do now is I'm going to put these in my calculator. 14.1, 24.3, 30.2, 38.3, 51.3, 20.5, 22.7, and then my y's, 2.59, 2.09, 1.57, 1.02, 0.74, 2.37, 2.21. Okay, so now I'm going to go to stats, test, linear regression t-test. I'm trying to prove that it's less than 0, so I'm going to put less than there. Calculate. So my t-value is negative 10.12. My p-value is less than 0.01. So this is going to be much less than any 1%. So we're going to reject Ho and say there's sufficient evidence. Okay. All right. All right. So let's go look at this, the predicted number of hours when x equals 19. So what I'm going to do is I'm going to make an equation. Go back into this. So y hat equals a is the y-intercept plus the slope, which is negative 0.05 times x, and my x is 19. So 3.38 minus 0.05 times 19, 2.43. 2.43 is my predicted value. So, or whoops, 2. Let me try this again. 3.38, 0.05. Let me go take this again. Okay. And my X was 19. 2.34 is what this. So I might have entered something wrong here. Whoops, minus 0.05. Sorry. I'm not sure what I did wrong there. It's supposed to be 2.34, so I made a mistake there. Now, on this one, we're going to do an 8% confidence interval. 8% confidence interval. This time I've got 7 data points. So 7 data points. My critical value is going to be, remember when it's inverse T, so it'd be 0.9, remember, for 80%, and then it's 7, or degrees frame, n minus 2, it's 5, sorry, n minus 2, so it's 5. So I got 7 data points. 1.476. So my error is going to be my critical value times my S of E, which is 0.1684, times the square root of 1 plus 1 divided by n plus n times, now this is going to be my predicted value minus the mean. I got to go find the mean real quick. So 0.243 or 2.43. Sorry about that. Let me make sure I entered these in here right. 14.1, 23.2, 2.09. Okay. So someone double check here. 2.37. All right. So now next thing I'm going to do is I'm going to do the predicted value, which is that minus the mean. I got to go to stat calc 1-bar stats to get the mean of the x's. 28.77 squared divided by 7 times the x value, which is 2.34, by the way. 2.34. Sorry about that. Times 7 times the sum of the x squareds. So that's this one. 6735.46 times the sum of the x's squared to 201.4 squared. Okay, and that actually should be minus there, minus that. So 1.476 times 0.1684, okay, times the square root of 1 plus 1/7 plus 7 times 2.34 minus 28.77 squared divided by 7, open parentheses, 7 times 6,735 minus 46, or times, 0.46. I'm sorry, I can't even read my own writing. 0.46 minus, it's the minus is right here. Sorry about that. Minus 201.4 squared. That gives me margin of error 0.341. And so I'm going to do that plus or minus a 2.34. So 2.34. So, okay, and we got a little off on this one. 2.34 minus 0.341. So I'm a little off on this. Let me double check here. Make sure I did this right. 684, 476, 6035, 146. 2.34 minus the mean, which is 28.77. Okay, so the answer is going to be 2.06 to 2.61. So state the null and alternate hypothesis for the slope. So the null hypothesis is beta equals 0. And what am I trying to prove? I'm trying to prove that it's less than 0. So I'm going to do Greek beta less than 0. The test statistic will be the same as above. I can go to stat test, linear regression t-test, and it's less than. The t-value is negative 10.02. P-value less than 0.1. So you reject the hoe, and there's sufficient evidence that the population slope's less than 0. 90% confidence interval, I can go to stat test linear regression t interval, 0.9, negative 0 or 0.066 to negative 0.044. So for every one increase in meter depth, the change, optimal change, falls within the interval. So it falls within the interval. Uh-oh, I missed one. Something went wrong. Negative 10.12. Oh, 10.02. Sorry. I believe I didn't copy that down right. Did I do it right down here? Okay, that was my fault. Just not copying the... Yeah. I just typed it. Didn't copy it right from my calculator. All right.